and gentlemen, viewers at home, welcome to Lankotheory Education Services Limited. Yes, we all are aware of what is going on in the world today, a pandemic disease called coronavirus. That has actually kept our students at home. But as an institution, we have taken it upon ourselves to be taking our lectures online. And today, it's going to be highly interesting. Our lecturer is ready for physics. Please, you have the floor. Thank you.
Here we go. As today math is 02/04/2020. So at this time we have basics. Under this we are interested on a concept called geometrical optics. In this geometrical optics, we have different topics under it. Plane mirror, we have refraction on a plane mirror, we have lenses and mirror, but we are interested in firstly picking the reflections on a plane mirror. Reflection on a plane mirror. Under this reflection on a plane mirror, there are some things that you are instructed to know. As the first one, you must be able to identify the definitions of reflections. At the end of this class, you must be able to identify the terms used in the reflections. At the end of the class, you must be able to identify the laws of reflections. And at the end of this class, you must be able to identify the applications of reflections. What is reflections? Reflection can be defined as the ability of wave to travel after striking the surface. In other words, reflection is defined as the reversing back of light ray. For example, suppose you have a mirror, a plane mirror on the surface. The surface of the plane mirror is this, and eventually there is a particular light incidented on the surface of this mirror. There will be a light that is going to reverse back to you in the same area. So when the light is incidented, the arrow here indicates that the light is moving toward the surface of the mirror, and there is another light going out, which is shown by this arrow. So you observe that the light that travel back to you in the same area is what you reverse as reflections. They have different types of reflections. There are two basic types of reflections. We have regular reflections, and two, we have irregular reflections. When you come about the word regular reflections, regular reflection is the type of reflection that occur on a smooth surface. For example, if you look at this surface, you observe that the surface is plane. So any reflection that occurs on this surface, it is known as regular reflections. But if you can observe another particular surface, check this kind of surface, you observe that this surface is not regular. It is surface that is rough. We call it scatter surface. Any reflection of the light that is dented on this, you call it irregular reflection. So irregular reflection can also be called diffuse or scatter reflection, while regular reflection can also call it smooth reflections. So I believe you're able to understand what they call regular reflections and irregular reflection. Regular reflection is the type of reflection that occur on a smooth surface. But any reflection that occur on a rough surface, you call it irregular reflections. So terms used in reflections: one, we have incident ray. Two, we have reflected ray. Three, we have normal. And take note, normal is not a ray. Four, we have angle of incidence. Angle of incidence. You can also call this incidented angle. Angle of incidence. Five, we have angle of reflections. Angle of reflection can also be called the reflected angle. And six, we have angle of glance. Angle of glance, or you call it glass angle. Seven, we have angle of deviations. Angle of deviations. So those are the terms used in reflections. For more understanding and easy way to identify the definition of term used in reflections, you can just consider the diagram below. This diagram, this is a particular plane mirror, and you can see the surface is a plane surface, which we call referred as smooth surface. Any reflection that occurs on this surface will be regular reflection because the surface is smooth. But if I'm considering the other types of surfaces which is irregular, the type of reflection you obtain will be irregular reflections. So if I'm considering this what smooth surface, any reflection that occurs on this, we call it smooth reflection. Suppose I have a light is painted on the surface of the mirror. I will observe that there is a particular light going out in the same media. So you observe that when this one is coming toward the mirror, you'll be interested in what will you call this. That's why we have incident ray, reflected ray, normal, angle of incident, angle of reflections, angle of glance, and angle of deviations. So if I can just pick a point here and I draw a particular line to show this one here, I will call it IR. I'll call this one R, small letter R, and likewise I observe that there is a particular angle between these two. So I call it I degree. There is angle here, I exactly call it R degree. This one we call it G degree, and likewise we have another one which is D degree. We trace this one down, there is an angle here, we call it D. This is D degree. So from this diagram, you can be able to define all the terms used in reflection. The first one is incident ray. If you want to define incident ray is the path of ray at which the light travel before striking the surface. You can observe that there is a particular arrow that is pointing down to the surface of the mirror. So the light that is traveling toward the surface of the mirror is showing reverse as incident ray. When this light has hit the mirror, it's going back to the wall in the same media. So the path at which the light travel after striking the surface is showing reverse as reflected ray. As you can see in the diagram, the arrow is indicating that one arrow is pointing upward and the other one is pointing downward. The one that is pointing downward is pointing toward the mirror and the other one is going out. The one that is coming is showing reverse as incident ray. While the one that is going out, we call it reflected ray. Then normal. Normal is a point, not a ray. You see that there is no any arrow in the normal. Normal is just a point at which the incident ray and reflected ray are coincide. That's where they meet. So if you observe this, incident ray is the path of ray at which the light travel before striking the surface. While the path of ray at which the light travel after striking the surface, we call it reflected ray. Then there is a point at which the incident ray and reflected ray are made. That point we call it normal. Normal is not a ray. Take note of that. And when you look at it, you have I degree here. This I degree is representing the angle of incident. Angle of incident is the angle between the incident ray and the normal. As you can see in the diagram, we have angle of refraction. Angle of refraction is the angle between the reflected ray and the normal, and we have angle of glance. So as you can see, I already explained that there is angle between the reflected ray and the normal, and that angle is known as angle of refraction, angle of reflection, which you can also reverse as reflected angle. Then there is another one which is angle of glance. Angle of glance is denoted by G. As you can see in the diagram, you can define it as the angle between the incident ray or reflected ray and the surfaces. So this is the surface of the mirror. The angle between the surface and the reflected ray, we call it angle of glance. It's the same thing. You can also define as the angle between the incident ray and the surfaces, and that is what you refer as angle of glance. But angle of deviations, we check this very well, you observe that the angle of deviation is D degree. As you can see from here to here, from the normal knowledge you have in mathematics, you will have seen that if this place is glance, this place must also be glance. We call it vertically opposite angle in mathematics. And the angle between the reflected ray and the point of the incident ray on the other media, that angle, we call it angle of deviations. So angle of deviation can be defined, expressed mathematically in this form as D degree is always equal to 2 times J degree, which simply means that the angle of deviation always twice the angle of glance. That is, the angle of deviation is 2 times the angle of glance. So if you know the glance angle, it is easy to determine the angle of division by multiplying the glance by 2. And if you are interested in defining the glance angle, you didn't remember the definition given to you as reflected ray to the surface is known as angle of glance. You can also go down by just dividing both sides by 2 this expression and observe that the glance angle is equal to division upon 2, which show that the angle of glance is always equal to the half of the angle of deviations. That's what the term is used in what? In reflection. And next term is what? Laws of reflections. There are 2 basic laws of reflection. One, you have the first law of reflection. The first law of reflection states that the incident ray, the reflected ray, and normal are all lying on the same plane surface. You will have seen this surface that there is no way you now have incident ray, so you don't have reflected ray. So whenever there is an incidental angle, we are reflecting a light, we turn it back to you. and that light we call it reflected ray. And if there is existence of reflected ray and the incident ray, then there must be a point where they meet, and that point we call it normal. So the incident ray, the reflected ray, and normal all lie on the same plane surface. That's the first law of reflection. The second law of reflection states that the angle of incident is always equal to the angle of reflections. It's normal thing you can often observe by yourself. You can see that there is angle between the normal here and the surfaces. The angle between the normal and the surface is exactly 90 degrees, and the normal and the surface is also 90 degrees. So if you could check this very well, you observe that from this diagram, the glass angle plus incidental angle can be equal to 90 degrees. And if you also check this one, the reflected angle plus glass angle is also equal to 90 degrees. If you check this very well, you observe that the left hand side of the equation is G plus I, while the left hand side of the equation is R plus G. And when you observe that the right hand side are equal to 90 degrees, and you already know mathematically that when you have the right hand side to be the same, then the left hand side is what? The same. So from these two claims, if I call this one equals a star, and I call this one equals a star star, if I equate star and star star, you observe that D degree plus I degree will be equal to R degree plus G degree. If you simplify for that, you have I degree equal to R degree. What do you have here? Plus G degree. If you transfer this one to the other side, you are going to have minus G degree. You observe that this G degree we can't. What do you have here? You have I degree is equal to what? R degree. So what does this one show? It is showing you the second law of reflection, which states that the angle of incident is equal to the angle of reflection. That is, the angle between the incident ray and the normal is the same thing as angle between the reflected ray and the normal. That is the laws of reflection. Then we have applications of reflection. Reflection has different kinds of application, but one of the two main applications of reflection. One, reflection, as already said earlier, I'm interested in explaining the applications of reflection. There are different applications of reflection, but the main two applications of reflection mostly used in preparation are in the productions of kaleidoscope and the periscope. But before I will explain on that, I would like to consider the diagram as I draw earlier. So if you consider the diagram above, you will observe that we have the incident ray, we have the reflected ray, we have the normal, we have the angle of incident, we have the angle of reflection, we have the angle of glance and angle of deviations. So one thing you have to consider in this diagram, you observe that the glass angle, the incident angle, the reflection angle, the glance angle, they are on a straight line, and sum of angle on a straight line is always equal to 180 degrees. So if I consider this diagram, I can say G degree plus I degree plus half degree plus G degree equal to 180 degrees. This is sum of angle on a straight line. And then sum of angle on a straight line. The sum of angle on a straight line is always equal to 180 degrees. So what do you have here? This is G degree, rearrange, plus G degree. This is incidental angle plus R degree equal to 180 degree. Our G plus G will give us 2G degree. I degree plus R degree equal to 180 degree. I can start this as equation 1. But I want to still know that the already said in the word, the second law of reflection. I explained before that the angle of incident is always equal to the angle of reflection. So if I could set I degree equal to R degree, I can put in bracket and write the second law of reflection, which states that the angle of incident is always equal to the angle of reflection. So in this case, we have this one to be 2G degree. This is incidental angle. We call it R degree. This another word, we have R degree. Everything is equal to 180 degree. So this is 2G degree. R plus R will give us what? 2R degree equal to 180 degree. So if you look at this very well, I can say this 2G is the same thing as division, because division angle is defined as 2 multiplied by the angle of glance. So which simply indicates that our division angle plus 2 reflection angle is equal to 180 degree. I can call this equation 2. And similarly, this 2G, you can just consider from this, we have 2G degree plus 2R degree equal to 180 degree. What is common here? 2 is common. You have G degree plus R degree equal to 180 degree. If you simplify further, as you can see, we have 2 into bracket of G plus R degree equal to 180 degree. If I divide both sides by 2 here, I'm going to have 2 into bracket of G degree plus R degree equal to 180 degree. If I divide by 2, upon 2. This will cancel away. This we have G degree plus R degree equal to 180 over 2 will give you 90 degree, which we can call this equation 3. And similarly, since you have already said that the angle of glance and the angle of refraction is the same as angle of incident, we can say G degree plus incidental angle is equal to 90 degree. This is equation 4. Ladies and gentlemen, we shall continue here tomorrow. You can also try to join us at Lankotheory Educational Service Limited. You can drop your contact or you copy our website. You can join us at www.lankoeducational.educational. You can drop your question and your contacts, and you can follow us on www.lankotheory.com.